All right, good morning. So as John said, I'm Christopher Ray. I am a principal worldwide security specialist at AWS, where I help lead the AI security domain. And what we do there is we look at how do we secure AI workloads, so security of AI, also using AI to improve security, and then also resiliency to AI-powered threats. With that, what I do is I basically try to help customers figure out how to apply AWS security best practices to services like SageMaker, Bedrock, Agent Core, and so on. So what we'll go through today is a keynote session on what it means to be starting with security when you're adopting AI. So to kind of kick things off and get everybody warmed up for the morning, who here is just starting to build things with AI today? Okay, good. Half, maybe, so of the group? Good. All right. Who's got a prototype, but they haven't launched it to production yet? A few, okay. Who's all the way into production and managing that today? All right, great. Okay. And last question here, are you confident that you have the right security controls applied to those workloads today? Cool. All right, well, we'll go through a very comprehensive way of thinking about applying the right controls to the right use cases at the right time. So what you'll walk away with from today's session is a framework on how to think about securing AI, whether that's something as basic as setting up a chatbot or whether that's doing agents or multi-agent applications. We'll go through a defense-in-depth architecture, looking at each of the different layers of security as they're being applied to something like a Bedrock implementation or Agent Core, using services that you may already be familiar with from being AWS customers. And the last part is we'll put that into action. We'll talk about what are the things that you should be thinking about on day one when you're starting to build that prototype, through to taking that prototype and getting it ready to be launched into production. And then what are the things that you could be thinking about applying for continuous improvement after that's been out in production. So one of the reasons for the massive increase in interest in AI is simply because it's a huge business driver. Some of the top things that I'm sure you're already taking advantage of today and that your employers and customers are also taking advantage of are, increased productivity and efficiency. AI is going to find itself into every nook and cranny of businesses where there is inefficiencies, which is to say, everywhere. We're going to see AI get embedded into infrastructure, applications, and throughout the supply chain. There's also tremendous cost savings that come from that, from being able to automate things and being able to give things autonomy to do that work. That's helping to innovate or accelerate innovation cycles in sectors like healthcare, where it's helping to do drug discovery. It also provides a competitive advantage. If your company is building something with AI and you're able to get better outcomes from that application than your competitor, then you've got a competitive advantage to get to market faster, offer more value to your customers, do things more efficiently. And lastly, it can also be helping to transform the customer service experience, either with like chatbots or maybe doing personalization of different recommendation engines, things like that. But also behind that is the driver for the security, which often comes from the compliance. So depending on what your region or industry is, you may have many different compliance frameworks that you need to be thinking about, especially as they apply to AI. That could be, yes? I can be a little louder. Okay. I could be like this all day. Compliance frameworks like ISO 42001 is the most common one that we hear for customers looking to make sure that they've got the right framework in place. European customers are certainly looking at the EU AI Act, which was the first set of compliance frameworks published regarding how to do AI in the European Union. Here in North America, you've got NIST AI RMF, that's another framework. And then you also have to think about if you've got an existing workload that's in healthcare or financial services, or it's a government workload, you still have to make sure that your workload is compliant for HIPAA, PCI, FedRAMP, et cetera. So with the evolution of AI, we have to think about, when we think about what the right controls are to apply, we have to think about how this has been evolving. So it started off with just basic machine learning models where you're looking at patterns in data, hidden trends and things like that that were in large data sets and big data workloads. Then you move into generative AI, and now you've got the capability to create text, code, images, video, audio. You're allowing it to create something based on what is learned and what that model has been trained on. And then you start to move into agents, and now agents are able to connect to APIs and tools and databases and other sources of knowledge. And so that creates a spectrum now between more human oversight versus less human oversight. Now you need to start thinking about what are the things that I need to start creating human-in-the-loop controls for these agentic AI workloads. Do I want to give full autonomy to this thing, or do I still want it to bubble something up to me and say, hey, here's my recommendation, what should I do with that? And you can think of a great example here, like, let's say, for example, the agent said, I need to drop this database table. That might be something that a human could make the decision to do, but you may or may not want the agent to delete your database. So that might be the kind of thing that you think, okay, that's the kind of thing where I need to put a control in place to verify that by human first. So this is what's going to form the foundation of us applying the right security controls. So as you're going through and thinking about implementing AI in your business, you're likely to go through a journey that kind of follows this particular map here of starting off with the use case and discovery, doing RFPs, figuring out what's the right model, what's the right framework, should we be building it on AWS or something that's on-prem or maybe even on device. And then you're going to start to go through and start thinking about things like, let's put together a POC, let's start to do some prototyping, let's get our teams brainstorming about what we can be building, what are the biggest pain points in our company that we could be applying AI to. And that's eventually going to get to a point where you need to show proof of value. And this is where a lot of times the prototypes that companies are building will get stuck in a bit of a purgatory because they're showing functional value, but they haven't been able to earn the trust to be able to launch that into production. It doesn't have the right privacy controls, or it doesn't have the right authentication and so on like that. And so part of what we're going to be looking at today are what are the things that I need to be applying early on so that I can help get that prototype from that purgatory into production. How can I be able to both move fast and stay secure with AI at the same time and not have AI be this pause button on innovation? So why does AI security matter? So 94% of executives identified that they said it was important for AI to be secured before it was deployed. Sounds good. 96% of technology professionals said that the introduction of AI agents actually introduced more risk, but that didn't stop them from having 98% of them say that they were going to be implementing more of them in the coming year. And then lastly, for those customers who did have security issues with AI applications and agents that have been deployed, 97% of them reported issues related to lack of proper access controls for those agents. So this tells a three-part story, right? The executives want to be seen as saying that they've got security as top of mind. Business pressures are going to force people to start deploying these things maybe with or without the right controls in place. And the consequences of that are that security events are going to continue to increase. So security is not a pause button on innovation. Security is actually the business enabler and the competitive differentiator that's going to make you be able to be deploying AI more confidently in your businesses. So here's our CEO, Matt Garman, and at reInvent a year and a half ago, the very first slide that he had in his keynote was that everything starts with security. And what that means within AWS is that security is the top priority at AWS. It is woven into our culture in the way that we do our business. It is woven into our business processes in the way that we build and release software, in the way that we write things to each other, in the way that we transact business. And so when we think about security, we think about being secure by design, making sure that everything that we build has that security concept baked into the design of the application or the process. secure by default. In what ways can we be building tools that make it easier for our customers to be secure without having to do any activities? A great example of that is a year or two ago, we made all S3 buckets encrypted by default, right? So it doesn't require any customer to take any action to encrypt that or to pick which key that they want to use. If you create a new S3 bucket, you automatically get encryption applied to that. That's the kind of thinking that we want to apply to all of our services so that we can better help our customers be secure by design and by default. And that goes into our culture as well. So one of the things that makes Amazon really kind of unique to work in is that there's a psychological safety net. You're never punished if you want to report something that you think might be a security thing. It could be a phishing attack, could be, hey, I might have accidentally uploaded something to ChatGPT that shouldn't have been uploaded. You are encouraged to report that. There is a psychological safety net that you don't always see in every other company, where employees are encouraged to be the security department themselves rather than relying on a dedicated security department. So when you're at Amazon scale and you've got millions of employees, every single one of them is a security engineer at some level. And then the second part is the community of security, and that's what you guys are here today. This is where we build some of the things that we're talking about. We're making these resources available, but it's really our community that takes that and helps that scale that as a force multiplier. So aligned to the NIST cybersecurity framework, we have a series of capabilities built into AWS around identify, protect, detect, respond, and remediate. You're probably familiar with services like KMS and IAM Access Analyzer and Guard Duty and Security Hub. All of these play a role in providing a complete security story for our customers. And all of these work together as well. So they're deeply integrated with each other, as well as all of the services such as a SageMaker, a Bedrock, Agent Core, and so on. One of the other things about working at Amazon scale is that we have the largest cloud, which also means that we get to see the most amount of traffic that's malicious in the world. And there are honeypots that we've set up. If there's a great blog, if you want to check it out, on something called MadPot, which is a gigantic honeypot network that we have created that attracts threat actors and malware and things like that. And we use that to learn more about what are the new techniques, what are the evolving ways that threats are being created, what are some novel new attack vectors that might be happening. And so all of that threat intelligence is something that's very unique and proprietary to Amazon because we have that at Amazon scale. And we've seen that across a variety and diversity of our customers, whether that's financial services companies, healthcare, government companies. It could also be technology, manufacturing. Each one of these sectors is going to have similar challenges, but then also something that's unique to those areas. And we get to learn from everybody, and everybody who's an AWS customer gets to benefit from that because that threat intelligence then goes into the services that you're then using. What we learn about different activities from MadPot, Cineris, and Mithra, which are some back-end services that we use for this, that goes into services like Guard Duty and Shield and Network Firewall and WAF. So every time that we're adding more customers to AWS, we're learning more things about the threats that are heading their way, and we put that back into the services to make everybody stronger who's part of AWS. And one example of that is we last year introduced Guard Duty Extended Threat Detection. And what this does is it helps identify common threat actor signatures across different activities. So you might see something over here on an Active Directory server, and then something over here on a DynamoDB server, and then something over here on CloudFront. And it's stitching all of those things together to be able to say, hey, this looks like it's the same threat actor doing these things here. So it's that kind of intelligence that we're able to surface because we have that kind of visibility baked into each of those services, reporting back to our threat intelligence teams. So when we talk about AI security, I mentioned before that there's three things that our team looks after. One is security for AI, which is how do I protect the actual AI workload itself, the models, the data? How do I make sure that inferencing and training mechanism is completely secured and resistant to tampering? The second part is AI for security. How can I use AI as a force multiplier to help my security teams? Maybe that's something as simple as summarizing tons of log files and to look for traffic. or maybe that's using something like our new AWS security agent service that was recently launched, which does autonomous pen testing on demand. So how can we use services like that, plus GuardDuty, which is using machine learning, to further scale and help our customers be able to react faster and with more capabilities? And then the third part is an emerging area, which is resilience to AI-powered threats. And so our customers coming to us looking for solutions around, let's say, more personalized phishing, deepfakes, polymorphic malware, things like that. We're building out capabilities there with our partners as well, so that we're providing solutions to help out with the way that AI can be misused by threat actors to do things at scale that are much more personalized and at a much faster speed than traditional defenses are prepared to deal with. And one example of that is the rate at which exploits are being able to be weaponized. So you've got CVEs being published, and then within minutes you've got validated exploits that can be used. So if you are doing patching and you're only doing patching, let's say once every 30 days, that's a window that's open for 29 days where you don't have a defense in place after that has been published. So how can we help customers tighten these things up and really do the security fundamentals to make sure that they are well defended against not only the human attackers, but also the humans who are AI-powered or AI-empowered? So the way that we think about this is you're not adding security to AI, you're building AI on top of security. You're building this on top of the most secure, or the cloud that's been engineered to be the most secure cloud out there. And so we want you to start with what you know and what you're using. Use the services that your team's already using, such as a GuardDuty or Security Hub and KMS. Just apply those to an AI workload, just like you would something that might be running in EC2 or EKS or DynamoDB. So what changes with AI? There's four primary things here. So first of all, LLMs are probabilistic. This is different than our typical security mindset because when you're setting up a firewall or an IAM policy, that's a deterministic thing. It's a proven capability that something is or is not on or off. But when you're dealing with something like an LLM, I could send the same request to an LLM a couple different times and get different responses back. So that makes it more challenging for me to be able to apply security controls to that. And also from a quality assurance tester, that makes it difficult to validate how many times do I need to run this test to prove that this thing works or doesn't work properly. So that becomes one of the challenges that we have to think about. Next one is that input becomes code. When you send a prompt into an AI agent or an LLM, there's no separating the instructions versus the content that you're sending it. And so that makes it difficult to be able to detect things like prompt injections or malicious requests. LLMs will also dynamically learn, depending on their capabilities around memory. They could have short-term memory and long-term memory. So this provides tremendous flexibility and capabilities for somebody who's building, let's say, a chatbot that needs to understand, all of your purchase history over the past year or something like that. But that also becomes an additional attack vector to think about in terms of poisoning that, right? I could go back to an LLM and say, no, I really think the price is $0, and eventually it might actually say, you're right, that the price of this object is actually $0. So that's another area of memory poisoning that we need to keep in mind. And then autonomy and agency. Now that you've given a generative AI tool the ability to connect to APIs, knowledge bases, and other services, now you have the ability for this to be able to start making decisions on its own. And so this is where you need to start thinking about what are the things that I need to give this for controls? When do I need to bubble something up to a human? What are the jobs that maybe only a human should be doing and not have an agent in there at all? So the fundamentals matter more than ever because the rate of change is accelerating. So a defense in depth strategy is the only viable strategy against these accelerating and evolving threats, and really more or less the eat your vegetables mentality of security here. So you need to get the basics right before you start scaling this out into productions. So we want to help you make the secure thing the easy thing to do, and make the insecure thing hard. And so we want to help you build guardrails so that your teams can move fast and stay secure at the same time and not have that be a trade-off. So 5 common anti-patterns that we've seen when we talk about securing AI is, oh, I'll just add security after we launch, right? We don't have time to do that now. We've got to get this to market. I got to show ROI to the board. We'll just add security after this. Well, there's a few things that you could be doing very early on, such as applying IAM controls around the AI applications, making sure that you're using encryption on the data, both in transit and in rest. You can start putting on some guardrails around that. So within Bedrock, you've got capabilities to do some basic filtering and say, you know, hey, let's not have the application respond to requests for political topics or religious topics or hate speech, things that you want it to avoid in your particular context. And you can do all of that on day one in the prototype. And it's only going to take a few minutes for you to be able to set many of these things up. And now you've got at least some basic controls that are being built in there. Next, overly privileged agents and users. Oftentimes we'll hear, oh, I'm just going to give it the same permissions that I have for my human user. Well, the problem there is that if you're giving a database agent the permissions to delete a database table and you're letting it have full autonomy, you may have some unintended consequences there. You may want to say, nope, the database bot can do everything except drop a table. I need to build a control in so that it notifies me that that's what it thinks that the right course of action is, and then allow a human to make that decision or not. Next would be code scanning is enough. Oftentimes we hear, I don't need to have any other stuff. I'm using Cloud Code Security, or I'm using GitHub Advanced Security. And that's great for looking at just code-related issues, but it's missing out on some of the other aspects of software vulnerabilities in application security. You're missing out on dynamic application testing. You're missing out on software composability, and you're missing out on actually being able to do some pen testing there. And so we recommend that you at least start with things like guard duty and inspector to be looking for vulnerabilities and threats and doing some incident response there. And then also consider using something like AWS Security Agent to help you do pen testing on more applications than you're currently doing today. Be able to do that faster, cheaper, and with deeper insights. You might have a pushback that there's no observability. Well, within services like CloudTrail, you can actually see a record of all of the agent's transactions and be able to use that both for troubleshooting as well as any sort of security investigations to be able to go back and say, why did the agent take this particular action? What was the input? What was the output that was there? And then lastly, agent governance. And I made a joke on LinkedIn yesterday, kind of a joke. It wasn't really a joke. But as I was flying, we released a brand new part of Agent Core called the Agent Registry. And so I had to update all my slides on the flight last night coming in because we had a brand new service to handle this. But now you've got a capability built into Agent Core where agents can be registered as well as MCP servers and so on. So now the argument about there's no way to identify how many agents you have, there are tools that are helping to address that. So when we talk about security for AI, it's actually application security that's implemented outside of the model. So you can think about this as sort of like an onion, right? So the LLM is at the very center of that, and then you've got these, and that's a probabilistic tool, right? And then you've got these concentric layers of deterministic controls that you need to put around that. So things like, a firewall, the IAM policies, the encryption, and so on. We need to make this redundant around the LLM so that if any one of those controls was to be compromised, the other ones would be there to help either mitigate the issue or at least slow it down. Also, model choice is actually drives a security outcome. So if you're a CISO or part of a security team, the ability to be able to swap out models at any time, add, modify, or remove a particular model from your applications doesn't require you to make any changes to your security infrastructure. Bedrock actually makes that completely agnostic. So I could be using Claude and then switch over to Nova and then switch over to OpenAI. And it's not going to require me to make any additional changes to my security infrastructure. For a DevOps team, that means that you can then move fast quickly, right? You can quickly validate a new model and be able to run one or more models together to do a particular task if you've got, let's say, a model that's better at text versus a model that's better at images and video. So going through the AWS AI portfolio, we are a full stack solution here. So starting at the very bottom with the silicon, we have our own chips, which is Inferentia, which is for inferencing, and Trainium, which is used to do model training. Those are specialized chips that are available from AWS, but you also have capabilities to use NVIDIA chips and other GPUs and CPUs for your compute. Wrapped in that, you've also got the Nitro layer, which is the hypervisor that we have that's doing virtual machine isolation and also doing encryption acceleration there as well. So that's going to help isolate all of the workloads from operator access, but also to make sure that that's not in a multi-tenant environment, that that's not surfacing any information from other customers to each other. Then you have capabilities like SageMaker. So if you've got your own large data sets and you want to build your own model versus using a foundational model, you can use Amazon SageMaker to take all of that data, do the cleanup of it, identify the lineage, do all the classifications, and then be able to run or train build a training model based on that. So there's a lot of capabilities in there around like data management, and that actually also contributes to a security outcome, right? So if I'm looking at a bunch of data that has a larger amount of bias in it, that might just be dirty data, but it also might be an indicator of compromise, that if somebody's going in and trying to poison my data, I can use tools that are built into SageMaker to be able to identify what that drift is, and then be able to make some corrective actions around that. Next up on the layer, you've got things like Amazon Bedrock, which is really the foundation, as it were, for a lot of the AI tools that we're building and using today. And so within there, you've got the capability to work with many different models. There's over 200 different models that can be plugged in there today. You've got capabilities such as being able to plug into knowledge bases, being able to do guardrails to protect against malicious inputs. And you've also got the agent core capability built into Bedrock. So if you need to build agents, these modules will help you be able to build that much faster and do that more securely. And we'll get into that in a second. Up above that, you have applications and agents, so things like Kiro. If you're using that to write code today, that's a tool for vibe coders to be able to do more productive and secure code writing, as well as things like QuickSuite, which is a desktop enterprise application. And then we've got our frontier agents, and this is where security agent is one of those that is using AI to do autonomous pen testing. But you've also got two other agents that were launched at the same time. Kiro Autonomous Agent, which is helping to use AI to write code more quickly and more efficiently. And the second is the AWS DevOps Agent, which is primarily used for doing prevention and incident response as capabilities. So let's say that you've got something that's failed, DevOps Agent could automatically decide to switch to a different region or switch to a different availability zone, things like that you're giving it the autonomy to make decisions on behalf of. And then we layer in the AWS security services. So all the services that we just saw for AI, all of the core AWS security services integrate with that. So I can use things like Security Hub, KMS, Guard Duty, WAF. All of those have a role in an AI workload. For example, I can put a WAF in front of Bedrock to help further prevent prompt injection, also to do rate limiting to help prevent unnecessary spend and in inferencing costs. I can use Amazon Inspector to help look at, maybe I'm doing my AI not in a Bedrock, maybe I'm doing it in EC2 or EKS. Well, I can use Inspector to look for vulnerabilities in those workloads as well. You've also got capabilities in identity. Things like Cognito can be used with AI workloads if you're not using something like Agent Core Identity. And you also want to use things like AWS IAM Access Analyzer, which is going to help you identify overly permissive accounts. And that's a great tool to be using before you're giving an agent any sort of permissions, is to say, am I giving it too many permissions? Is the permissions I'm giving to the Chris bot the same as Chris, and should those be different? And then down below, you've got the core services, things like AWS Config, Systems Manager, private link, VPC, all of these contribute to AI workloads as well. So how do we know what to secure and when? So now let's talk about how to align the right controls to the right use cases at the right time. So there are three primary use cases that we see for AI. The first is what we consider to be AI that answers. So this is like any sort of chatbot where you're working with a fundamental or a foundational model that you haven't trained with any proprietary data. It's not connected to any sort of external systems. It's just you're working directly with, let's say, ChatGPT. Or you're doing document summarization or basic content generation. The main things that you want to think about here from a security perspective are making sure that you've got the right identity and access controls. You've got basic data encryption, content safety filters put into place, and that you've got comprehensive monitoring going on for that application. Next, we move into AI that connects, and now you're taking that same LLM and you're giving it new toys to play with. You're giving it a database, a knowledge base, you're giving it full access to the web. Things that are outside of the model itself that you want it to be informed about. So for example, the LLM isn't going to know what the weather is today, but by connecting that to a weather service, I can pull that information back in. So now I need to think about things like data classification and data loss prevention, both on the inputs coming in as well as the outputs going out. I need to be thinking about fine-grained access controls around who can actually run these applications against something that has a RAG pipeline. I need to be thinking about output validation. Before that data goes back out to the user who made the request, am I sure that that's not confidential information or has any sort of PII in that? And then knowledge-based security. In addition to the LLM and Bedrock, or let's say that I'm using, have I locked down the database? Have I locked down the storage? Have I locked down the web server that this is connecting to as well? Is that route also been secured? And then the third one is AI that acts. And this is where we have agents and multi-agent workloads where we're orchestrating that. This is where we're building either agent-to-agent or MCP servers to help the agents discover the tools and each other. This is where we've got code that's being executed, not just being written, but being executed. And then we've also got the concept of physical AI. So as we start to see AI being moved into on-device workloads, this is another place where if this is being embedded into, let's say, an autonomous vehicle or robotic systems, that's going to have some additional things that we need to think about. So the security requirements here, now you need to really make sure that you're starting off with agent identity and giving it a distinct identity different than a human identity. So both from a tracking perspective in the logs, but also to give that even more fine-grained access controls to only the things that it needs to get access to. We think about least privileged authorization, building in the human in the loop controls. You can do that with things like the Strands SDK if you're using the Strands framework to build agents. You want to think about behavioral monitoring. How do I know what is an anomalous activity from my agent? Is it going sideways on its own, or was there somebody that was influencing that to go sideways? And then lastly, you want to think about agentic governance. And so as your teams are building out your blueprints for what your agents should look like and what those capabilities are and what your security requirements are, you want to make sure that you're starting to bake that into governance so that everyone is building with the same blueprints and so that you're able to identify that across your enterprise. So where is AI being embedded into your organization today? Questions? Yes? Let's hold off until the end. Yep. Thanks. So where is AI being embedded into your organization today, and what does it have access to? So these are some questions that CISOs are constantly having to figure out is, how do I have visibility into shadow AI that might be going on in my organization? So if you're familiar with the concept of defense in depth, there's typically like 8 or 9 different layers depending on which source you look at. You're looking at things like infrastructure, data protection, network protection, application protection, identity, threat detection, incident response, governance, and compliance. But it's a lot of things to think about, especially for people that are not security experts. And so what we wanted to do was be able to simplify this down into 3 things to think about as you're starting to ask, do you have the right controls in the right places? So we looked at the use cases before. Now we're going to start dissecting this and looking at the layers here. So First is the infrastructure layer. This is where we're looking at hardware isolation. We're offering that today through things like Nitro Hypervisor, as well as Bedrock itself has its own isolation called Mantle as well. You're looking at things like network segmentation, putting in DDoS protection, and also doing session isolation. So things that are really trying to isolate and protect the workload itself. The second is around identity and data security. Here you want to make sure that you're thinking about identity for agents, the access control. You're also applying data encryption to data at rest and data in transit. You're classifying your data. You're making sure that you've identified, is this PII data? Is this classified data? Is this top secret data? That has a huge impact on what the agent is going to be able to work with. Credential management and tool access are the other parts. And then you have AI application security. This layer, you're thinking about the content filtering, you're thinking about prompt injection defense, output validation, and behavioral monitoring. And then over on the right, you've got governance, because this spans all of the different layers. So things like logging, configuration management, audit reporting, and more recently, things like agents and MCP registries. So let's go layer by layer. So as I look at infrastructure here, I'm going to be thinking about things like turning on or taking advantage of the Amazon Nitro system, which is hardware enforced hypervisor that's got encryption and a hardware root of trust. You want to lock down your VPCs with segmentation there, put a network firewall in place to inspect encrypted traffic, and put some basic DDoS protection in place. That could start off with something as easy as WAF, but you could also move into Shield when you're more advanced. Then from the AI-specific side, you want to think about things like, does it make sense for your business to be using Trainium or Inferentia GPUs versus NVIDIA? Take a look at the cost performance benefits there. Mantle provides zero operator access in isolated inferencing so that even AWS cannot take a look at what's happening within your inferencing. Amazon Bedrock has built-in capabilities for managed infrastructure, making sure that your data never gets back to AWS. We can't take a look at that. We're also not using that to train our models, and we're not providing that information back to the foundational models if you're using those as well. And then lastly, Amazon Bedrock Agent Core. Within the runtime itself, there's session-level isolation for the virtual machines, and also VPC isolation. On the second layer for identity and data security, some of the same controls that we've been talking about, IAM Access Analyzer, KMS, Secrets Manager. These things can be used to help apply identity controls and data protection. For AI-specific capabilities, you certainly want to turn on Agent Core Identity as one of the first things that you set up. You can use things like OAuth and Entra IDs there, and that's purpose-built to build agents with least privileged access. Then you've got Agent Core Gateway. This is a module that allows you to then set up tools, and that could be, I want to build an MCP server, or that could be, I simply want to connect to maybe a Salesforce or an Asana or some other tool that already has an MCP server that you're accessing. Agent Core Memory provides encrypted memory so that your sessions aren't leaking between different instances. And Agent Core Policy is transparency for how the agent is reasoning. And then on layer 3, for the AI application security, here's where you want to put things that are more application security specific, like WAF, Inspector, Config, Guard Duty, and Security Hub. These are going to help do threat detection and incident response for your workloads. And then some additional capabilities to think about here, specific to AI, obviously guardrails. There's also some contextual grounding, where you can help reduce the amount of hallucinations by giving it things that are that you say, this is a true statement, right? Like I'm giving it my pricing information, never deviate from this pricing information. So now that's going to reduce the likelihood that the agent is going to hallucinate on some type of request like that. You've also got observability evaluations. Guard Duty Extended Threat Detection is going to help identify things even deeper in places like EC2 and EKS. And then you've got capabilities like Security Agent, but then also SageMaker Clarify, which can help surface bias that might be in your models, which could be a potential indicator of compromise for data poisoning. So governance spans all of these layers as well, services like config, organizations, artifact, and so on. And so now if we put these two together, you've got the rows of being the individual layers of AI, identity, and infrastructure mapped to the use cases that you have, the AI that answers, that connects, and that acts. And so this provides some guidance on what should I be thinking about in each of these different stages. And certainly in your organizations, you probably are doing more than just one application, so this can apply to a lot of different scenarios. Amazon Bedrock Guardrails is a combination of both deterministic and probabilistic controls. So first of all, you're filtering the data before it's reaching the model. You're setting things up like word and phrase filters or denied topics. And then you've got probabilistic controls, which are looking for more of like the safety measures, right? So broad categories of topics that you may want to avoid or not have get used in there. And so this works built into the workload automatically as the prompts are coming in. I think we covered most of these. So just to kind of talk about how these would all work together. So let's take a prompt injection example. I could put 5 layers of things together to help try to prevent against this. So I could start with WAF, which is going to be doing like a regex filter ahead, and I could be removing certain queries coming in. I could be blocking bots. I could be doing rate limiting. That's certainly one level. After that, you've got Bedrock Guardrails. That's going to be looking for some more of those topics and things that were there. If you've gotten past those, then you've got the agent core identity. Now you're locking down access to particular resources and making sure that you're validating the authentication and authorization of the identity that's accessing that. Then I can set up SCPs on a bucket level or on a database level for things like S3 or DynamoDB. And then lastly, I can be using things like GuardDuty and CloudTrail to be looking for any sort of anomalous behavior here. So again, kind of stacking combinations of the core AWS security services plus these features that are built into Bedrock and Agent Core, I can achieve protections around this type of use case. And then similarly for data exfiltration, if I'm concerned that the agent is going to be leaking information, I could be considering things like strict access policies in VPC, only sending information over private link, using a network firewall to do packet inspection, AWS WAF, gateway, Agent Core Gateway for that, certificate manager and KMS to encrypt the data so that if it does leak for whatever reason, it's still encrypted. And then of course using guardrails and Macy to scan for PII information as well. So I can use these again as a stack to solve a particular security job to be done here. All right, so what would it mean to your business if you were able to do pen testing on all of your applications faster, more frequently, with the wider insights into all of your applications. Today we hear from customers that they're only doing pen testing on maybe a handful of applications. It's only happening maybe once or quarterly at best. So there's a large amount of applications that remain exposed and not being addressed today. And so we want to introduce AWS Security Agent to help customers be able to take this agentic workload and be able to use it to improve their application security. So it is AI-powered pen testing. You have SAST, DAST, and SCA built in along with autonomous pen testing capabilities, and that's all baked into a single solution. The agent is context aware, so as you feed it documentation about like your design docs, your infrastructure as code, your user stories, your threat models, it's going to learn about what your application is and then start to build a customized attack plan for that. Then after it's built that attack plan, it's then going to execute that against the endpoints that you've given it. And that could be anywhere. It could be on AWS, it could be at Azure, GCP. As long as there's a path between the agent and your application, you can test this anywhere. And one of the great things about the service is it also is only going to come back with validated security risks. Unlike generating a bunch of false positives of possibilities, Security Agent is going to come back to you with evidence that it was actually able to exploit a cross-site scripting attack or a SQL injection attack or an information disclosure. And it's going to do that in a way that's going to help reduce false positives and reduce your alert fatigue. So some of the business value around that is fast results, increased frequency. You can do this across the 90 to 95% of the applications that are not getting tested today. You're going to get deeper insights than you're getting from just a singular tool like SAST, DAST, or SCA today. There's capabilities for you to be able to remediate code in your GitHub repos, and there's also a huge benefit for increased ROI here as well. And one of my favorite testimonials that came from our recent beta of this came from a customer called Bamboo Health, where they said this was identifying things that their tools and teams hadn't discovered before. And this was, they felt like this was not just another scanner, but actually something that was helping them on the Defender side. So this is a great example of being able to use an agentic workload to improve a security outcome. Now you can do the pen testing much more frequently and across a wider scope. So end of the day, the most effective security teams are not saying no to AI. They're saying, here's how we can make that happen. Yes, and. So how do you know that you're doing all of this right? So the three main phases that we want to roll this out into is aligning the right controls to the right time frame. So foundational would be anything that you're doing to get from prototype or zero to prototype. Enhanced would be, now that I've got a prototype, I want to get that ready to put into production. What are the additional things I need to be thinking about there? And then last, advanced, where now that you've launched, what you want to do is be able to continuously improve that, the security and the governance of that particular workload. So wrapping up, what are the next steps for you? Well, how do you know if you're doing everything right? One of the first things that you can do is you can take advantage of something that we have called SHIP, which is a security health improvement program. And this is a free security assessment that you can take and get from us, where we will come in and take a look at 9 different categories of security issues in your account and come back to you with some prescriptive guidance to say, hey, you need to make these changes, or maybe go take this or go to these resources to improve your security posture further. Second, if you're a little bit more DIY, you can take a look at the security reference architecture. We recently published an AI security and governance version of the SRA. So this is a document that gives you the information on how to bring this back to your teams and what the right architecture patterns would look like for that. There's the well-architected framework tool and custom lenses for machine learning and Gen AI. You can use AWS config and use some of the conformance packs to things like HIPAA compliance or FedRAMP compliance. That can greatly help you find things that are deviations from those particular standards. Security agent we talked about, and then of course forums like this where you can interact with both AWS staff, but then also the community around you who may have already been solving some of these problems and you didn't even know that that person is sitting at your table. So SHIP. So wrapping up, so security is a team sport. As you go through the rest of today, definitely share what you've learned with each other and also online. If there's something that's really stood out to you, definitely share that on LinkedIn or other channels. Ask a lot of questions, challenge the assumptions, and push deeper on making sure that you come out of this with a complete understanding. And lastly, the relationships that you make here with the other people who think differently about security is probably worth more than the content that you're actually ingesting today. So definitely take advantage of this environment. All right, so just to wrap up, 3 use cases: AI that answers, connects, and acts. 3 layers: infrastructure, identity and data, and AI application. And 3 phases of rolling that out to production: foundational, enhanced, and advanced. So align the right security controls to the right use cases at the right time. And with this, we believe that you will see that security is a foundation for you to actually move faster with AI innovation. All right. And then here's some great further sessions for you to check out today on some of these topics as well. So, all right, thank you very much.